Hello, I'm Dr. Hannan Azhar. I'm from Canterbury Christchurch University in the United Kingdom, and today I will uh, talk to you about a tool, which is a forensics tool to capture radio signals using software-defined radio. Now, what I'll do first is actually give you a brief introduction of the spectrum forensics, the importance of it, and then I will tell you about the basics about the SDR, which is software defined, and then I will give you the introduction to the software itself, and then how the software is used in two case test scenario here, simulated scenario. One of them was fixed code garage door attack, and the other one is walkie-talkie in terror attack. Now, wireless data communication, as you know, that is being widely used nowadays. Our life has been, dependent on the wireless devices, and we are immersed into the wireless technologies and devices around us. And when you talk about the smart cities, Industry 4 or 5 and IoT, and the wireless technologies are important technologies. Now, because of the dependence, of course, the crime and that's will be happening is related to the wireless system. Now, what was we've seen that sometimes the terrorists are using the wireless technologies to do to share the information, or while the crime is happening, or creating networks of the conversation or the communications while they're working as a group. So it is important, while the crime is happening, or while this crime is unfolding, or the attackers remain at large, to be able to capture the signals and to stop the crime if it's possible, or trying to gather the intelligence and trying to find out what information is going on, what conversation is going on. So in terms of when you're doing the capture of the signal, now one of the things we need to be very cautious is about the technique or the signals, because this is a volatile and this is a signal that is live data. Now, from the forensics side of it, you need to be extremely detailed while the way you are doing it, what devices you're using it, the technology, and the steps. You need to be very clearly document so that it is accurate and repeatable if the same devices and same techniques are used. So that will create the authenticity of the evidence gathered. And this is a area of network forensics, or the live forensics. So you need to be very, very cautious, and you need to be very, very you need to be competent and knowledgeable on the subject matter to know exactly what you're doing. Now, the other thing is about the legal issues about the working with these technologies. And so if you want to experiment, or even to do research or to investigate in this area, you need to be able to understand the legalities. For example, Wireless Telegraph Act and the Communication Act govern the radio use within the United Kingdom. The Ofcom is a governing body. They do the spectrum management in the United Kingdom, and their regulations are there. They tell you exactly what you can do and what you cannot do, if you need a license or you don't need a license. If you are working on a short range radio signals in a low power distance, maybe you will be exempted by the regulations made by Ofcom. So the 17 reference is very important in the paper, where it gives you more detailed guidelines about what are the cases, in which cases you could be exempted without license. You could do this experiment. And then Investigatory Power Act is also important, because it defines the lawful authority for carrying out an interception of signals. So that is important, that if you need a warrant, and in which case, what you should do to get a warrant while you do the interception. Now, this is a very standard architecture picture of the SDR, or software defined radio. And as you can see, that a lot of these were using software based hardware rather than real hardware, like digital mixer, low pass filter, and because it's using software, so you can use the program to create all these things. You can tune the bandwidth, or you can tune the this frequency, sample rate. Uh, you can you can adjust the modulation. So it is very easy for doing the investigation, because it's independent of the modulation techniques or the sampling rate. You can use the same device to capture range of RF signals. Just to give you an introduction, this is a very simple antenna that used to capture the radio, and then it gets converted analog to digital ADC, and then it goes to digital mixer. And here is basically, it is a bit complicated. It's out of the scope of this presentation, but what it does is it creates two signal, which is one signal but complex signal. One is the imaginary part, and the other one is the real part, and that's the way it captures. And this tool that we developed is also capture the complex baseband signal, which has two parts, imaginary and real part. So basically, the fundamental advantage here is using software to create the system, so that you can do different experiments, or you can capture different signals using the same tool and the same device. Now, different libraries are used, as you can imagine, when you're working with creating a software. And because it's Python, so these are all Python libraries. For example, hashlib is used for hashing of the signals. This is the first library, is used for interfacing with the SDR device, the real device. The configuration, streaming, choosing the streaming formats, all those for GPS tagging, and also UTC timestamping. Use the GPSD libraries. There are a lot of other standard libraries like NumPy and so on. The details are in the paper. Now, these are log files. These are important for forensic sense, because you need to create the evidential files, and this creates the capture of the data. You can see the capture of the file here, and the hashing of the file. And this is the capture complex 16S. And as I say, we use CS8 as the stream format, which is basically 8 bits per component of this, of the signal, because the signal will have two components: is imaginary and real part. So 8 plus 8, 16. So that's why 16 comes here. But again, the hashing is important for the integrity of the data, so that when it goes handing it over in different software for more analysis or other things, so you need to check that the original data hasn't changed. And so that this is the hash value has been created, one for SHA-256 and the MD5. There's a lot of other information, like the device information here, the latitude, longitude and altitude as well, the device itself here, the time of the creation. These are all very standard in forensics evidential creation. And as you can see here, what the HackerF you were doing, and it created the log file using timestamp, and this is the different action points have been taken, and this is the GPS log file as well. Okay. The more information here about the commands. Now this is a CLI based tool, and using help command you'll see all the list of commands. Then list command is show you the list of devices. The info command show you the the information about the device and what it can do really. The full range here, it shows you the range of frequency it can work on, and then the sampling rate range here, bandwidth range. Also here you can see that the stream formats. This device, the HackerF device, was supporting this various stream format, basically the resolution of the data, and we had to use the native format CS8, and the other are higher resolution. It wasn't very effective because of the Python use a Python program, and we thought that maybe the low level language would be more appropriate, but this paper is about the implementation using Python, because the availability of the libraries and using Python. easily available. Okay, so next here you can see that more command here, like the status command. It shows you the device, the HackerF, and the another device called RTL-SDR, and software different radio. And then one of the devices is recording status, and the other one is not recording. And you can see that the frequency range, frequency that it was recording, and also you can see that the time, and the samples been recorded already, and the file size there. These are the file structure there: log file, report file, and output files. So it's creating the sample files here, and all these are very important when you putting a case in the court for to create an evidential proof of a crime happened. So it is, if at the same time something happened, and if you create it in the same place where the crime happened, if you gather all this information, if you compile all this and putting it as a case, and then of course that it has some merit in the court, depending on the what you captured and what crime happened. Now here, as you can see here, that you have more information about how you're setting the gain, like 35 dB, setting the sample rate 20 millions of samples per second, again the streaming format, how to set the streaming format, and there are other information like the frequency, sample rate, and so on. So let's talk about the crime scene. We simulated crime scene we used, and one of them was the walkie-talkie in the terror attack, and which is basically a terrorist group has been confined within a warehouse with workers, and they're using walkie-talkie. And because walkie-talkie uses this sort of range of frequency, so we thought, okay, how can we simulate that using SDR? Now, the one problem we had was that we were not allowed to capture that because of the radio band, and to capture those. So to avoid the legality, or to be within the legality, I should say, what we did was we, instead capturing the specific PMR 446 band, we captured 104.330 megahertz. Basically, the both signals are the same modulations, everything else was same. So it shows the proof of concept, basically, that the device can capture with all the necessary evidential data and artifacts in a forensical sound manner. Now, in terms of the device we used, HackerF1, as you can see here in the middle here, it is a half duplex transceiver, so it's capable of receiving and transmitting. In this case, it's receiving in this example. And then we have this cable here, which is, you can see that is a shielded USB cable, okay, and it has the 3 ferrite bits here, 1, 2, and 3. These are to suppress the high frequency electromagnetic frequency, so that it is less noise and less interference. This antenna here, which is the 50 ohm telescopic antenna that covers frequency range from 75 megahertz to 1 gigahertz. And we haven't used a Faraday case here, which is artificial environment, because we didn't need that, because we are capturing a radio frequency, FM radio band. So we used the GPS as well here, so that we want to see the full potential of the tool to be able to capture and report. So that's been shown here. We can see that this is an example of the before the capture. It shows like what has been this current setting, and then you start setting the frequency 104.30 megahertz, and then sample rate, bandwidth, and so on. GPS set the CPS true here, and then you see this has been set up, and the results have been shown, and then you start capturing, and it shows the recording and the specific frequency, and time, and that shows that the successful recording of the data. And this report file shows the successful capture of the data using the hashed values as well, and a lot of other information like the what time of the day, what the GPS location of the this crime incident happened, and or the latitude, longitude, the device information, what device was used in this investigation, so that you have the credibility of the evidence in the court. So you're trying to put this all information as a sort of evidential file. Now the next want to report is about the intruder attack of the garage door. And basically this is a 110, is 10 bits of data in amplitude modulated data, ASK, on off data. And fixed door means that this garage has got a fixed code, and you send the data, and if you know this data, and then you can actually open the door. So basically you brute force the data, the 10 bits to the 10 different combination. But if you use the Brugian sequence, then you can reduce the number of combination, and very cleverly you can hack this 8 to 12 bit garage door in 8.2 seconds. That's been demonstrated by Sami Kamakar, who is the researcher, security researcher. You can go to this website, you can find more information about this. So what we did was basically we simulated this experiment using a transmitter and receiver. In this case, the HackRF, and the other one is RTL SDR, which is a capable receiving from 25 megahertz to 1750 megahertz with internal oscillator and aluminum enclosure as well to reduce noise. And there's another antenna here as well we used to receiving antenna. This is transmitting antenna. So whole experiment was inside a Faraday case, so that to avoid the legal issues, to ensure that transmitted signals are contained and do not interfere with any other devices. And it was very low power as well, so we could do this experiment. And because it was confined and the GPS receiver was not effective because everything was, no signal was outside the Faraday box. So while you do that, we could actually show that, okay, the experiment recorded all the information, that the transmitted frequency that was captured, okay, and what time of the day. And by the way, this is another tool which is called RFPW non tool, and which is basically used for transmitting the signal from that HackRF to that the RTL SDR. In this case, HackRF was the key fob. It was playing the role of a key fob, and the RTL SDR, if I show you very quickly, this was the garage door receiver. And this is a report file generated as well. Information such as logging, GPS locations, UTS, all this information could be compiled to prove that event or that crime happened. And also in the future, maybe the signal could be reproduced with the original actual device, and compare that forensic capture to prove that it is the forensic capture is actually they are the same signal. So again, another experiment to showcase that this tool can create a lot of data, information, or the metadata and evidential data that could be useful and has got forensics merits. Now, in summary, then we created the tool for acquiring radio spectrum, which is forensically sound, we believe, and we did 2 experiments conducted, and successfully showed the use of the tool. Now, in terms of the resolution of the data format, the signal format, we could not use the high resolution 32-bit because of, as I said already, because of the high-level language of the Python. So that we like to improve in the future. We want to improve GPS logging as well using GPX, the standard format. We want to include the GPS, a visual display of the spectrum, so that the live activities of radio activities could be presented in front of the investigator. And also the file compression is very important, because without the compression it's quite a huge file. So thank you very much. If you have any questions, please ask.